Okay, so this is going to go on page 82 when we are done. All right. And I'm going to get you started, and then I'm going to give you some time to work together to finish the rest of this up. But we've got this checklist here, and we're going to figure out which one of these properties apply to which figures. And you can do this a few different ways. I think like coloring it in is probably the easiest. But if I look at the property of both pair of opposite sides being parallel. So is that true for a rectangle? Are both pair of opposite sides parallel? Yes. Okay, so I'm going to color that in. All right. And then, actually, I don't like it like that, so let's do it this way. All right, and then what about for a rhombus? Are both pair of opposite sides parallel? Yes. Okay, what about for a square? Yes. What about for all parallelograms? Yes. Okay, so this property here, is this property a rectangle property, a rhombus property, a square property, or a parallelogram property? Parallelogram. Okay, so this is a parallelogram property. So if I know that from the beginning, I know it applies to all parallelograms. It doesn't matter what kind of parallelogram it is. And then these three are special parallelograms. So if I'm going to color this box in, these three automatically get colored in. Does that make sense? So you can kind of look at it that way as well. So you're going to go through and for each property decide, you know, which, some of them you color in all the boxes, some of them you do not. It just depends on which one it is. And then if you look down here on the angles, I have something on here twice. The all four angles are right angles. It's on there twice too. We're just going to mark out the last one so it's not confusing because it's not really an extra thing. Okay? So we give you about 5 minutes. You can use your notes. You can talk to the people at your table. Get the chart filled in, and then we'll go through it together. Okay? So let's look at this from a straight property standpoint, because I heard a lot of good discussion about what it is, and y'all were looking stuff up, and you know your properties, and that's good, but I want you to think about what the property itself, theorem-wise, actually directly applies to. So opposite sides being congruent, that is what kind of property? Parallelogram, okay? So since it is a parallelogram property, I know that it's going to apply to all parallelograms. And if I'm going to color this one in, then these three are all special kinds of parallelograms, so it applies to rectangles, rhombus, and square as well. Make sense? Okay. All sides congruent. What does that directly relate to? Rhombus. Okay. So it directly relates to a rhombus. It's a rhombus property, and I can't, what kind, is it rectangle then rhombus? I can't see. Rectangle, rhombus, square. Okay, I couldn't remember what order it was in. So if it directly relates to a rhombus, is it going to relate to all rectangles? No. All rhombus? Of course. And then if it works for a rhombus, works for a square, and then is it true for all parallelograms? No. So it's just those two. Does that make sense? Good? Okay. So then we look at the angles. Sum of the angles is 360. What does that directly relate to? Actually, a quadrilateral. And are all of these here quadrilaterals? Yes, so it is true for all of them. And then we have opposite angles congruent. What does that directly relate to? Parallelogram. Okay, so since it's true for all parallelograms, I can color in all of these. And then all four angles are right angles. What does that directly relate to? Rectangle. Okay, so this is a rectangle property, and that your first column is rectangle. So if it works for all rectangles, is it going to work for all rhombi? No. All squares? Yes. And then all parallelograms? No. Okay, good. All right, consecutive angles supplementary. What is that a direct property of? Parallelograms. So since it works for all parallelograms, it's true for all of them. Okay. Now, could it, these all four angles being right angles, does it apply to some things that are rhombus? Yes, but not all of them. That's how we're not filling it in. Okay, we good on the angles? All right, so let's look at the diagonals. Diagonals bisect each other. What does that directly relate to? Parallelogram. Okay, so all of these are shaded in. All right, diagonals congruent. What does that directly relate to? Rectangles. So if I'm going to color in a rectangle, I'm not coloring in the rhombus. I am coloring in the square. Okay. Diagonals perpendicular. What does that relate to? Rhombi. All right, so that means not all rectangles, but yes, all rhombi. Do I color in square? Yes. Rhombi. All right, diagonals bisect opposite angles is rhombi. So, same one as I did before. Okay? All right, are we good? Any questions? So, which column is all completely shaded in for all of them? Square. Square has it all. Okay, always. Any questions? We good? All right. So now you can kind of keep that handy and let's look at your family tree. It's a family tree.
I wish I had a family or a tree.
And this is going on page 83 when we're done. And we're going to look at how these all relate to each other, okay? So our overarching concept here is quadrilaterals. So what is something that's true about all quadrilaterals? They have 4 sides, and what's their sum of their angles? 360. So we've got 4 sides and 360 degrees. Right? And so you could just be a plain old quadrilateral and not have anything special about you. You could be a quadrilateral and also belong to the parallelogram family, or a quadrilateral and also belong to the kite family, or a quadrilateral and also belong to the trapezoid family. So those are 3 basic categories in quadrilaterals. A trapezoid is never going to be a parallelogram and vice versa. They're in 3 separate things. So we're going to start with our parallelograms. And we are going to label on there. We could label a whole lot of things, but the only thing we're actually going to label on this picture is what makes it that figure by definition. Okay, so by definition, what makes a parallelogram a parallelogram? Okay, so that's what I'm going to label. So the parallel sides is what makes it a parallelogram. So that's our first property, is that both pair of opposite sides are parallel. Okay, so what's something else we know about parallelograms? Opposite angles are congruent. Okay, both pair opposite angles congruent. Something else. Okay, good. Consecutive angles are supplementary. Okay, good. Diagonals bisect each other. Okay, good. Both pair of opposite sides congruent. Yes. What? Okay, the diagonal divides it into 2 congruent triangles. That is one of the 2 things that are true about it, and even have theorems that we're not writing up here. But yes, it's not that it's not matter. It's not that it doesn't matter. It's just that I don't really know why I didn't put it up here. But there's one thing I want to put up there, even though that is true. That's a good one. There's another one you might give me. Yes. Okay, go ahead. Yes, that's by definition. It's a quadrilateral with both pair of opposite sides. Right. So you do have, there are other figures where you would have opposite sides parallel, and it may even be exactly 1 pair or 2 pair rather, but it has to be a quadrilateral. That's the question. Yes. Okay, the sum of the angles is 360. That is a quadrilateral property, though, not a parallelogram property, but you're on the right track. Yes? Okay, good. So that's the one that I wanted, is that one pair, opposite sides, parallel and congruent. And then in parentheses here, we're going to put condition, because I'm not saying that it's only one pair that are parallel and congruent. They both are, but if that's what you have, that's a condition to make it a parallelogram, and that's important to know too. The other thing that isn't listed up on here besides the diagonal and the congruent triangles is if there's one right angle, there's 4 right angles. But that's kind of taken care of with some other things, so I just didn't add it to my list. Okay, so those 6 things there are true for every parallelogram ever, plus the stuff that's true about a quadrilateral, which is the 4 sides and the 360 degrees. Now, if you're a parallelogram, you could just be a plain old parallelogram, or you could be one of the special parallelograms, starting with a rectangle. By definition, what makes a rectangle a rectangle? 4 right angles, okay? It has to be a parallelogram. Well, it is a parallelogram, but it's 4 right angles, right? So that's our first property, 4 right angles. And besides the fact that it has 4 right angles, what's the diagonals are congruent? Good. So those are the 2 things that are special to rectangles, in addition to everything else about parallelograms, right? All right, so maybe if you're a parallelogram, maybe you're a rectangle, maybe you're not, and maybe you're a rhombus. So by definition, what makes a rhombus a rhombus? Good. 4 congruent sides. And then what else? Good. All right, diagonals are perpendicular. Good. The diagonals bisect opposite angles. Again, those 3 things in addition to everything about parallelograms, right? We good? All right, so then if you are a rectangle or a rhombus, it's possible you're even more specialized and you are a square. There's not additional things to list with the square because the square has 4 right angles and 4 congruent sides, and it's just has everything. It is the perfect parallelogram. It's also called a what kind of quadrilateral? Regular, okay? It is a regular quadrilateral because it's equilateral and equiangular. It's a special one. All right, any questions? All right, let's go back up here. Now, if you're a quadrilateral and you're not any type of parallelogram, it is possible that you could be a kite, okay? Can you be a kite and a parallelogram at the same time? No, okay? So, by definition, what makes a kite a kite? Here we go. Good. So, that's what we're going to label right here. We have exactly 2 pair of congruent consecutive sides. Exactly 2 pair of congruent consecutive sides. Diagonals are not congruent. Diagonals are perpendicular. Okay, so let's put that on there. And then we'll get to the other things you're trying to get out of your brains. What were you trying to get at, Ellie? Okay, good. So remember with a kite, is it possible for the diagonals to bisect each other? No, because if the diagonals bisect each other, that forces it to be a parallelogram. So you do get one diagonal that gets bisected, so we have to say that it's exactly one diagonal bisected. What else? Good. And so I need to say exactly one pair, opposite angles, congruent. Okay, well, that's good. So basically that's it. Is it the angles that are congruent that get bisected? No, you either get bisected or you're congruent, but you're not both, right? And so this is exactly one pair opposite angles bisected. Those are your important things about a kite. And then there's not any kind of special kites, like you're a kite or you're not. Then that's it. No fancy. Doesn't get any fancier than that. At least you can fly. Yes, that is a good thing. All right, so then if you are a quadrilateral and you're not a parallelogram and you're not a kite, you could be a trapezoid. So what you got? All of them? Exactly one. Okay. Who are you trying to talk to? My earrings are kites? Are they close? They're close to being kites. We don't have enough information, right? Okay. Good observation, though. Good observation. All right. So by definition, what makes a trapezoid is exactly one pair opposite sides parallel. Okay, so if you are just a regular old trapezoid, there wasn't another theorem, but there's some other things we know. Yes, sir, Cameron? Not necessarily. Okay, a pair of base angles are congruent. Is that true in every trapezoid? And isosceles trapezoids. Okay, so you're giving me the definition of base angles. It has some base angles, but since they don't have anything like measurement-wise that's necessarily special and just a generic trapezoid. No. Okay, are all of the consecutive angles supplementary here? No, only which ones? The same side interior ones, right? Okay, so I think that's kind of what you were trying to get at. It's the leg ones, right? It's not all, listen, shh, it's not all consecutive angles. It's not that these two are supplementary, these two are not, okay? You can't be all supplementary, because if one angle is supplementary to both consecutive angles, that makes it a parallelogram, okay? No, not in every trapezoid. These are base angles, and that's not true. But what is true is that, don't give up. So leg angles, which aren't really called leg angles, and that's why we're, are supplementary. And that's because, and somebody did use these words, they are same side interior angles. Okay. It's because they're same side interior angles, your leg angles. And then the third thing, I don't know that you would necessarily come up with, because I wanted it on here, and I think you know it, but it doesn't really fit with the rest of these properties. But it's about the mid-segment. Okay, so the length of the mid-segment, we know that the mid-segment, good, is equal to half the sum of the bases. And that was the other important thing I wanted you to have there. Okay. So that's for any trapezoid ever, any of them. And then if you are a trapezoid, you can be a more specialized trapezoid, right? In addition to these three things, if you are an isosceles trapezoid, what makes an isosceles trapezoid an isosceles trapezoid? Okay. But what makes it an isosceles trapezoid? The legs are congruent. Good. And if you notice, it goes 1, 3, 5. And I don't know what happened to 4. 4 like disappeared, so we're going to put in a 4 here because we need it. So there's 4. Okay. So here, this is what makes it a trapezoid, and then there's my isosceles. So for isosceles trapezoid, we have congruent legs. All right. Then the base angles. That's what we were trying to say on the first one, but that's not true in every trapezoid. It's only if it's isosceles, just like an isosceles triangle. And in this case, both pair base angles are congruent. What else is true? Isosceles trapezoid.
It looks like an isosceles triangle with
The diagonals are congruent. Good. Diagonals are congruent. All right. So there are all of your important things. Now, sometimes with some of these, there's some other things you could figure out based on properties you know, but those are the big ones, all right? So I want to look at this thing as a whole. Let's see if I can make the whole thing fit on here. It's kind of, sort of. Well, you can see the word square. Well, let's do it this way. Well, fit is the height, and then you can see it. All right. So you can use this. Obviously, it's kind of all of your properties in one spot. Plus, it will really help you with the always, sometimes, never types of questions. So if I said, and your answers are either always, sometimes, or never, a square is a parallelogram. Always. A parallelogram is a square. Sometimes. Now notice the way you're going on the family tree. When I said a square is a parallelogram, it's always. When you're going up, it's always. A parallelogram is a square. Sometimes, if you have to go down and get it. What if I said a parallelogram is a kite? Never. And notice how I'm jumping categories? When you go left and right, that's a never. Okay? Does that make sense to you? Okay, hang on. That's when you skip major categories. If I go left and right here, does that make it a never? What if I said is a rectangle is a rhombus? Sometimes, because the only time that would be true is when it's a square. So I am going left and right here, but I didn't jump major categories. Okay? Yes, sir. Yeah, I mean, you may need to look, if you need to look specific examples, but this kind of has it all in one place, yeah, for you. Okay? Any questions at all? Are we good? Does that help you some? Yes? Awesome. All right, so go ahead and get those glued in. Oh, I also want to say this. Listen, shh. As I was putting grades in, it was clear to me that some of you think that Schoology doesn't exist anymore or something. I don't know. But what I did was, because we haven't had any tests or quizzes or anything, I put a quiz in there and I gave everybody 100, all right? Which means nobody should be failing. Because even if you had a 40 for a homework average, which is really easy to obtain, then that average with that 100 for the quiz would have meant that you were at a 70. However, there are quite a few people failing because some people have put absolutely nothing in Schoology. You know that's an expectation. It is on the calendar every single day. Even the days when I was not here, that no matter what I had going on, that calendar was updated in Schoology. And in Schoology, when you have something to submit to me, it pops up on the right-hand side, too, no matter what course you're in. So you trying to tell me you had no idea, I don't buy it, don't even bother. Okay? Huh? He didn't try, because I said all this before anybody tried, but